All right, reflections. So we just finished up translations, and now we're moving on to another transformation. So a reflection changes the shape only by its position again. So it doesn't actually change the size of the shape or anything like that. It just changes where it is. So as you know, a reflection is when you look in the mirror or something like that, or you look into a reflection in a pool, and then everything kind of flips. So that is basically what a reflection is. All right, so it represents a mirror image of a figure. The original figure is called the pre-image, and the figure is called the image. So I know this is really weird, but pre-image means before, and then image means the after. All right, reflections have isometry because the pre-image and the image are congruent. Okay, so since both the old and the new, the original and the new are both equal to each other, they're the same shape and size, we call that an isometry. Iso means equal, metry means measure. Okay, so let's look at the most common reflections. So we have through the origin. When you reflect through the origin, let's take a look at what happens to the actual numbers. So let's look here. Point A has -4, then A prime is +4. B is -3, B prime is +3, C is -2, C prime is 2. So as you can see, all the numbers stayed the same except the sign switched, or the sign changed, excuse me. So the sign was negative, now it's positive. So we denote that, or we put that right there. So X went from its original state, now it's the opposite. So I know it looks kind of backwards because up here the negative was here, and then down here the negative's down here. But don't think of it like that. Just think when you see the negative next to a variable, it just means to change the sign. If it was negative already, make it positive. If it was positive, then make it negative. That's all it means. Likewise, the y, let's look at the y. So the y value here was 2, then the y value here was -2. B was 4, B prime was -4, C was 3, C prime -3. So as you can see, the y values also changed signs. So y was normal, and then it became opposite. So the original became opposite. The original was positive for the y's, and now the new is opposite. They're all negative. Okay? So that's what happens when you reflect through the origin. So the shape over here that you see is an exact representation of that. I'm not going to do all the points, but you see here we have A. A is at -4, 2, and then A prime is at 4, -2. Okay? So that's pretty much how that works. And another thing that's really interesting to note is that if you connect A and A prime, they make a line that goes through the origin. And if you connect B and B prime, they make a line that goes through the origin. If you connect C and C prime, it makes a line that goes to the origin as well. Okay, so that's something that you can use to check your work. All right, reflecting over this line, y equals x. So here's the line right here. That's y equals x. That's what it looks like. That's our line of reflection. For this problem, our reflection was actually a point. Oops, sorry. It was a point, it was not a line. Okay, but for this one, now we're talking about lines of reflection. So we see here that we have -4, and then the -4 goes over there. For B, the -3, and then the -3 for B prime goes over there to the y spot. For C, there's the 0, and then the 0 kind of switches. So as you can see here, the x starts in the normal x position, but then it goes to the y spot after we reflect it. So let's take a look at the y's. So the y was 2, but now it becomes x. It switches to the x spot. Same thing 4. So basically, these all just switch places. Okay? So y was here, now y is here. So here in the little bubble, the little cloud down here, it says switch the x and the y. That's all you need to do. So over here, it said change the signs of x and y. That's what it says, change the signs of x and y. So they stay in the same spot, but the signs change. This time, the signs don't change at all, but they switch spots. All right, and again, let's just look at what happens when we connect the points. So A to A prime makes a line that crosses this line of reflection, and it's also perpendicular. B to B prime, same thing. It crosses the line of reflection, and it's perpendicular to the line of reflection. C to C prime, same thing. Crosses, and it's perpendicular. Boom. All right. Number, just kidding, not number, over the x-axis. Okay, first of all, let's identify where the x-axis is right here. You guys have got to remember that. It says x, so it's not that hard to remember. All right, so here we have a 4 for A and a -4 for A prime, -3 for B, -3 for B prime. Did I say? I meant to say -4 for A, sorry. -2 for C, -2 for C prime. So as you can see, the x's stay the same. Nothing happens. And then we have 2 and -2, 4, -4, 3, -3. Those are all the y values. So as you can see, these stay in the same spot, but the y sign changes. So change the sign of y. I wrote that in a little cloud down there. And then if you look over here, let's connect the points and see what happens. A to A prime, that's perpendicular. The line from B to B prime, that's perpendicular. And the line from C to C prime, that's also perpendicular. And something that I did not say before that was true before is that if you count 1, 2, so from the line of reflection to A is 2 spaces. And then from A prime to the line of reflection is also 2 spaces. Same thing with B, 4 spaces that way. 1, 2, 3, 4 spaces that way. So what I'm trying to say is that these are equal on both sides. So A is from A to the line of reflection is equal to the other side. Same thing here. They're equal on both sides. And these are equal on both sides. All right, that same thing was true over here. This was equal to this side is equal to this side, and these two sides are equal. The same thing is also true over here. That's how reflections work. They're going to be equal on both sides. All right, next we have this line of reflection. This should look familiar. It looks just like this one, but it's pointing in the opposite direction. So let's take a look at the numbers. So we have 2 and it changes to a -2, and it also changes spots. It changes positions. 4 to -4, 3 to -3. So if you notice, it starts off with the x in the normal x position, but then it switches, and now x is second for some reason, and it becomes opposite. It becomes negative in this case. If it started off negative, it would have ended up positive. All right, let's take a look at these. So we have this, this, and this, and if you notice, they all become opposite. Now 0 is a neutral number, so it's not going to become opposite because the opposite of 0 is just 0. There's no such thing as -0. So we've got y and -y. So you not only switch x and y, they switch places, but they both change signs. Very important. All right, so just like before, we have A to A prime. It's a straight line, it's perpendicular, and it's equal on both sides. B to B prime. It's a straight line perpendicular to the line of reflection, and it's equal on both sides. And then C to C prime. Perpendicular, and it's equal on both sides. All right, next we have over the y-axis. So let's identify the y-axis right here. Okay, and let's take a look at the numbers. We have 4, -4 becomes 4, -3 becomes 3, -2 becomes 2. Stays in the same spot, so that's fine, but it changed signs. Now let's take a look here, 2, 2, 4, 4, 3, 3. Again, y stays in the same spot, and it also keeps the same sign. So the only thing that changes when you reflect over the y-axis is the x sign. So when you reflect over the y-axis, the x sign is what changes. Let's take a look at the graph. So from A to A prime, we have a nice perpendicular line, and 1, 2, 3, 4, and 1, 2, 3, 4. It's equal on both sides. Same thing with C. 1, 2, 1, 2, equal on both sides. Same thing with B. 1, 2, 3, 1, 2, 3. So again, we're seeing that these are equal or congruent on both sides. Okay, so each of these are congruent on both sides. All right, we're not going to worry about that one. All right, so now we're talking about the line of reflection and all that that means. Let me erase this so I can redo it. Okay, so the line of reflection is going to be a perpendicular bisector. We did that in the first 6 weeks, perpendicular bisectors. So we're going to have to relearn how to do that. So let's look at the first example for this. Okay, so it says graph the line of reflection and find its equation. We're actually going to do this backwards. Yes, there's a way you can look at the graph and tell, but we're going to do it backwards. We're going to do the equation first, then we're going to graph it. So the first step is you need to find the slope. So to find the slope, pick a point. I'm going to pick point A because why not? Join it to point A prime and find the slope. So that's going to be 1, 2, 1, 2, 3, 4. So both of these numbers are positive, so that will be up 4 and then right 2. So the slope is positive 4 over positive 2, which reduces to 2 over 1, or you can write it as 2. It doesn't really matter. Can I get rid of that? Okay, so we did step 1. Step 2, find the midpoint. So I'm going to use a capital M for midpoint. Lowercase m is slope, capital M is midpoint. Now you can use the midpoint formula, or you can use the graph. I'm going to use the graph because it's quicker. So using the graph, I see that 1, 2, 1, 2, 3, 4. Okay, so just do the halfway thing. So half of 2 would be 1. Half of 4 would be 2. So just go down 2, and then you see where it goes right there. That's halfway. So that's going to be right there at 0, 1. Did not mean to use that color. Okay, so again, that's 0, 1. So we start at the origin, and we have to go up 1, but we didn't go right or left. So it's going to be 0, 1. All right, third step, find the perpendicular slope. The original slope was 2, or 2 over 1. So when you do the perpendicular slope, you flip it, and you change the sign. So now it's negative 1/2. All right, last step, we're going to use the y minus y1 equals m times x minus x1. This is important. Here's your x1, y1. Here is your slope. So again, this is your x1, y1, and that is your slope. So this is going to become, that's going to be 1, right, because that's our new y1. And then the slope is negative 1/2. And then the new x1 is 0. All right, so let's clean this up a bit. Technically, this is the equation, but let's clean it up. So y minus 1, and then we have negative 1/2 times x, because x minus 0 is just x. All right, and I want to actually change this to slope-intercept form, basically get y by itself. So I'm going to do plus 1 to get rid of that minus 1, and I'm left with negative 1/2 x plus 1. There's my equation. I'm going to go ahead and graph it. Let me get rid of all of this. Okay, so we see that our y-intercept is 1. So we've already got that right there. And then we see that our slope is negative 1 over 2. So that means we go down 1, right 2. Sorry, down 1, right 2. Down 1, right 2. Now I ran out of space, so I'm going to go the opposite direction. Up 1, left 2. Up 1, left 2. And there you go. There it is. And as you can see, the lines connecting A prime, B prime, C prime are all perpendicular to the line that we just drew. Graph the line of reflection and find its equation. Same situation, so let's do the same thing again. First, we're going to find the slope. So this time I'm going to use B and B prime. Why not? Doesn't really matter. Let's find the slope. So the rise is 1, 2, 3, 4. And the run is 1, 2, 3, 4, 5, 6. So that's negative 4 because I had to go down, positive 6. So that's going to be negative 4 over 6. Simplify that, that's negative 2 over 3. So the original slope is negative 2 over 3. Now we're going to find the midpoint, capital M for midpoint. All right, so now to find the midpoint, just go halfway. So instead of going down 4, go down 2. Instead of going to the right 6, go to the right 3. And boom, there's your midpoint. And that's going to be at, this is my origin, I have to go over 2, up 2. So that's 2, 2. All right, and now third, find the perpendicular slope. So the perpendicular slope is just going to be this, but flip it and change the sign. So that's going to be 3 over 2. Now it's positive because it was negative before. So again, these two are the most important from here on. This is going to be your new x1, y1. This is going to be your slope, of course. So that's going to be y minus 2 equals, instead of m, put a 3 over 2 times x minus 2, because that's our new x1. All right, just checking. Okay. So there you go. There is your equation. So you can leave it like this. The other one I changed because it had a 0 in it. You can also change this one if you'd like. Or you can leave it just like this. Actually, let me distribute first. So if I want to change this to y equals, then I can just do that. Then that would be 3 over 2x minus 3. So 3 over 2 times negative 2 is just negative 3. Then I'll add 2 to both sides. And that'll give me y equals 3 over 2x minus 1. Okay, so let me go ahead and graph that. Let me erase all of this. All right, so the midpoint was there, don't forget. So we have negative 1, then 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. That's my slope, right? My slope was 3 over 2. And then you go the opposite direction. 1, 2, 3, 1, 2. And there is your line. Okay, so again, you could have left it in slope-intercept form, or you can change it to point-slope form. Really does not matter.